let's go to page 161, and this is lesson 3.3, and this lesson is to prove lines are parallel. So let's go over the postulate 16, corresponding angle converse. So this one says if two lines are cut by a transversal, so two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. And the reason this is called converse, because remember it's got switched. Before was that if two lines are cut by a transversal, two parallel lines cut by a transversal, then the corresponding angles are congruent. So right now converse means to switch the if then, right? So right now if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So it goes either way. Okay? So if corresponding angles are congruent, then lines are parallel, or if the lines are parallel, the corresponding angle would be congruent. Okay? So so instead of trying to remember the name, it's better to just go and write down what actually the theorem is. Okay, and because those are common sense, so it's easier to remember. Okay, so you can memorize it both forward and backward, right? So again, if two lines are cut by a transversal, two parallel lines are cut by a transversal, the corresponding angles are congruent. Vice versa. Okay, if the corresponding angles are congruent, then the lines are parallel. Okay, so now let's go and apply it in calculation for algebra. Okay, so find the value of x when m, n are parallel lines. Okay, well if the two lines are parallel, that means the corresponding angles are congruent. So if they are congruent, you set it equal to each other. And then after, just matter of using algebra to solve. So first minus 5 on both sides. So you end up with, so minus 5, you get 3x equal to 60. Again, the reason is subtract 5 from each side. Then after that, to solve for x, you divide by 3 on both sides. Divide each side by 3, and you get x equal to 20. Okay? Okay. So now let's go to more theorems. So this is similar to the postulate that we just went through. Okay? So this is alternate interior angles converse. Again, if the alternate interior angles are congruent, then the two lines are parallel. Okay? If the alternate exterior angles are congruent, then the lines are parallel. Okay? Over here, if the same side or the consecutive angles, interior angles are supplementary, then then the two lines are parallel. Okay? So again, we cover all the converse from before. Okay? Now here's an example about solving the real world problem. Snake patterns. How can you tell whether the size of the patterns are parallel in photo of a diamondback snake? So if you look at this over here, so if this angle and this angle are congruent, these are alternate interior angles. So if alternate interior angles are congruent, then the two lines are parallel. Okay. Okay. Let's go to example 3. Okay, to prove that alternate interior angles converse. So so you got two lines. Again, notice there's no arrow, so you don't know if they're parallel or not. Okay. If they're parallel, you can see the red arrow like this. So if you see the marking, it tells you they are parallel. If you don't see it, you cannot assume. So you don't know if they are parallel or not. You don't know. So you cannot assume either way. Okay, just don't assume anything when you don't see the marking. Okay, so given angle 4 and angle 5, so you try to prove the theorem. So angle 4 and angle 5, these are alternate angles are congruent. So you want to prove that if the alternate angles are congruent, then the lines are parallel. Okay, so again, angle 4, angle 5 are congruent. You want to prove that the lines are parallel. Okay, so first you write the given. So angle 4, angle 5 are congruent. Then after that, so when you're doing the proof of this type, you're going to use a lot of vertical angles. Okay, so just be aware of that. So over here, you say angle 1, angle 4 are congruent, and the reason for it is the vertical angles are congruent. So instead of writing the name, because sometimes the names are harder to memorize, it's better to just go and write down, just write down the facts. So again, over here, vertical angles are congruent. So you can just write down vertical angles are congruent. So angle 4 is congruent to angle 5. Angle 1 is congruent to angle 4. So you got angle 1 is congruent to angle 5. Okay. So over here, if you use substitution, that's acceptable also. But most of the time, you just use transitive property. Okay. So you can just use a link, right? 1 congruent to 4, 4 congruent to 5. So you just link it together. So you got angle 1 is congruent to angle 5. But if you notice, angle 1 and angle 5 are corresponding angles, right? So if corresponding angles are congruent, then the lines are parallel, and that's your proof. Okay, so G is parallel to H, and the reason for that, again, instead of writing down the name, okay, it's better to just go and, if you can, just write down the name, or just say, if corresponding angles are congruent, then the lines are parallel. Okay, something like that. Okay, let's go to example 4. Write a paragraph proof. Okay, in the figure, R is parallel to S. Okay, so when you read this sentence, what you do is put a red marks on that. So you want to write down all the facts. Okay, so R is parallel to S, so you want to make this marking like this. It says angle 1 is congruent to angle 3, so angle 1 is congruent to angle 3. So what you want to do is you want to use a hash mark like this. Angle 1, the arc. Okay, so that way you know that they are congruent. Okay. So now plane in action. So we're not doing a full proof yet. This will just kind of help you to know how to set up, how to do the proof. Okay. So you can write down. So just go and do the marking. So this one you want to do so angle 2 and look at angle 2 and 3. So these are alternate interior angles, right? So you can kind of plan ahead. So you want to prove that P is parallel to Q. Okay. So you got angle 1 and 3. So you want to do the alternate angle, and then from there it says, okay, so from here you want to do the corresponding angles. So you want to say angle 1 and angle 2 are congruent, and then after that you got angle 2 and angle 3 are congruent. Then because of that, then these two lines are parallel. Okay. You also can prove that R and S are parallel because so if 1 and 3 are congruent, okay, then so we will prove that these two are parallel, right? Okay. So if these two are parallel, then notice all these three angles are congruent. So when angle 1 and angle 2 are congruent, then these are the corresponding angles. Therefore, these two are parallel. Okay. So again, so this one first is you draw the picture and you do all the markings and kind of learn how to plan ahead. Okay. So here, let's go over this. So it is given that R is parallel to S, so that corresponding angles partial angle 1 is congruent to angle 2. Okay. And then it is also given that angle 1 is congruent to angle 3, and then angle 2 congruent to angle 2. Angle 2 congruent to angle 3. So use the transitive property. Okay. So you can get that. So you can from here to here you can link together, so you get 2 congruent to 3. And if the alternate interior angles are congruent, then P and Q are parallel. Okay. So you can know how to kind of plan ahead before you kind of jump into it. Okay, so here's another transitive property for parallel lines. Okay, so transitive property of parallel lines. It says if two lines are parallel to the same line, then they're parallel to each other. So it says if P is parallel to Q and Q is parallel to R, then P is parallel to R. So in other words, this parallel to this and this is parallel to that, and then this will parallel to that. So basically all of them would be parallel. And to apply that, if you look at the flag, okay, so you can see that the top strip is parallel to the bottom because S1 is parallel to S2, S2 is parallel to S3, S3 is parallel to S4, and so forth. Therefore, S1 is parallel to S13. So it means everything's all parallel. So again, if you have two lines parallel to the third line, then all of them will be all parallel.